All right, everybody should have Rhino open, and we'll go ahead and go to Grasshopper as well. And just as a reminder, this is one way to install the add-on. So you want to go to File in Grasshopper, Special Folders, Component Folder, and wherever you have that file saved, you'll just want to drag it from there into here. Should be elk, G-A-H. Drag it in here, and you'll need to do the unblocking, which is you right-click Properties, and you should have a button here that says Unblock. While you're doing that, I never went through the exercise in class, but food for Rhino, which I mentioned last week, it's food for numeral 4 Rhino. It's where all the plugins we are downloading comes from. So you just have to create a username here. It's elk is the one we're using this week. So the file that I downloaded email is in when this comes up, be right here. So download, they need your email. Once you sign up, then you can download them all for free. So once you get that file in this the library folder, go ahead and close Grasshopper and do the unload command. Unload Grasshopper unload plugin. And then go ahead and start it back up. And if all went well, under Extra, you should have a box called Elk. Does anybody not have a box called Elk?
Whenever I try to do it from the file menu, it says that it asks me to open it in another folder.
Right. All right, so the first thing we're going to do is deal with some data. It is from the USGS. The link is in the notes file that's in that. All right. So in the folder geo file is a text file with link. I'm going to go to this directory. And bring that up on. Get out of my way. All right, and I can't remember what the acronym stands for. STRM. This is the satellite data. Okay. Shuttle Radar Topography Mission. And there's 2 data sets that the USGS has that's for free. The first one, the number 1, is the 1 arcsecond, and the second is the 3 arcsecond. Just a little review for. So I have to look all this up. So, all right, latitude, always parallel. Longitude, radial lines. So when you're dealing with latitude, longitude, you guys remember you have something northing, something westing, or something easting, something south, something west. So we're going to be looking up something in Lawrence. In Lawrence, it's approximately 38 degrees north. Just measuring from the equator up, and then I think it's 95 degrees west. Now the way the data set works is that it's treating west has a negative number, so it counts wherever the, I can't remember whatever the 0 line is, prime meridian or something. It's everything to the east is going to be a positive number, everything to the west is a negative number. You don't ever see it written as a negative number, but in the data set we'll have to treat it that way just so that it will pull stuff up. So we'll remember that. So and the way that the data set is broken up is that they've taken these little chunks. If you go into, let's do STRM1, because that's the tighter data. So here's region definitions, JPEG. You can just look up here if you want. So these are the size of those squares that is the data for North America. So they just broke the folders up into these regions. And so each one of those is 1 degree square in terms of, in this degree understanding. And it's always the bottom left in the way that they define it. So we'll be looking for something that falls between 38 and 39 and 95 and 96. So this is where the negative thing is important. So in terms of the longitude, since it's counting backwards, this would be negative 95, and this would be negative 96. And then 38 and 39, those are the coordinates. So the data, the way that they label it, when you pull it down, you'll be looking for a data set that's 38 north, 96 west. Which is confusing because we're looking for something in the 95, but that's the way that they define it. It works both the same for the STM, SRTM1 and the SRTM3. I already downloaded this for you, but this is where you can find this other data set. So you'll look in the folder where it says high res and low res, and you should find a folder that has, or a file in that directory. The low res, north 38 west 096, high res north 38 0. So same file name, data set, much bigger. This is 25 meg, the low res is 2 meg. And the data that's in there is it's coordinate data in terms of degrees, and then the elevation. That's what the actual metadata that you're reading in. Just the way that I said we'd pick Potter Lake as a site for today. So I'm just always using Google Maps. So I said Lawrence, Kansas. This is the way I find that stuff. When you pull up Google Maps, and depending on which version you're looking at, it might be different, but if you're not clicking on something that is a site or an item, then it should, there you go, give you the latitude and longitude for that site. So I said Potter Lake. There we go. So for tonight, let's deal with the center of our site as 38.96 north, negative 9.25, or negative, sorry, 95.25. And actually, this, just to have a context of what these are, so 1 degree is 60 miles, and then, so it's actually, even a 0.01 is quite a distance, so let's take it to 3 digits. That would be 0 and 9. So that's the 60 miles is an important thing to remember, because there's the big data set. It's going to have 21,000 data points approximately on one axis and 21,000 on the other. So if you accidentally tell it to make a surface with all of them, it will crash Rhino in about 3 seconds, because 21,000, that's still way too big of a data set for Rhino. So So we'll be trying to figure out what little tiny postage stamp of data do we want, and so that's why we'll leave it here to the 3 decimal places. Okay. So in Grasshopper, we're going to start just with that thing here, because we want to make something that lets us select the latitude and longitude, select the amount of the topography and of the site that we want to render, and then import that data and show it. So I'm going to start with 2 sliders. So you can double click, or they're under input. And where are they? Number slider. Okay, so I'm going to set the range for these, and you double click on slider, pull that up, or right click, say edit. I'm going to set this range just to the data set so that we don't try to grab stuff that's outside of it. So in this case, it's going to be, so this will be my latitude, which is the north-south, so I'm going to just set it at 38. Minimum, 39 maximum. And I'm going to leave it at 3 decimal points to match our selector. So go there.
You set the minimum to 38.001?
Just 38.00. Oh, sorry, 39. I misspoke. So 38 minimum, 39 maximum. So we should have, that's our data set in terms of north-south. Second slider, this one, have to remember the negative data, so minimum is going to be -96, maximum -95. We want it to be 3 decimal places, which is already set at. Say OK. And here's where you can double click on the number, and you can type in the exact value that we had pulled for Potter Lake. All right. Now, in terms of deciding the how big the site, how much are we going to pull from that center in terms of the site for our context? That's where it matters to kind of understand how big the data set is. I'm going to create one more slider, and we'll copy this one after we edit it. So this one, I'm going to set the minimum at 0.001 and the maximum at 0.01. And in terms of actual distance, 0.01 of a degree, the easy way to check this is I can't remember exactly. I think it's 20,800. No. All right, ask Google when you can't remember. $24,900. So latitude, longitude is 360 degrees, so 24,900 divided by 360 degrees. That's where you get the 60 miles per side. So we just set our range at what is 0.001 of 1 degree, so that times 0.001. So 0.069, that times 5,280 feet in a mile. So each point 001 is 365 feet. So we may even want to narrow it up. Just depends on your site and how much context you want to pull in. So, but that's the numbers we're talking about at the bottom range here. So we have that set. I'm going to copy that and paste that. So I have two of them. So this way I can set my latitude and longitude, and then for each of them we'll set how much we add and subtract from it. Okay, so we brought in under the extra tab ELK. ELK has a few components. The first, all of them except for one, SRTM topo, is to deal with OpenStreetMap data. So we'll grab this one, SRTM topo. And it has three inputs. File path to the data file that we talked about downloading from the USGS, and then it has a latitude and longitude domain. So it says what is your square that you want to pull out of this data, and it says locally defined, and it gives a suggested 0 to 1. So you could feed it 0 to 1 for any data set and it would work, but it figures it out for each one, even if you feed it. So if we feed it this, it should work. You don't have to transform it down to a 0-1 domain. So, but it is a domain like we worked with last time, where you're going to give it a bottom and a top of the range. And so domains, if you remember, are under math, box for domain. And we're going to construct a domain for each, for the latitude and for the longitude. So I'm going to grab one of those, copy and paste it. I have two. All right, I'm going to wait to, one thing you have to be really careful with, if you accidentally tell it to do the whole data set, it will crash. So we're going to go ahead and save now, just in case, and then make sure we don't do anything until we're all set. So I'm not going to wire these up yet. Let's go ahead and save, put this wherever you want. All right, so what I want to do with this number is create that range with this at the center. So I'm going to add this number to this and subtract this number from this. So I'm going to grab under math, under operations, a plus and a minus. So we're going to subtract the number to get the low range and add the number to get the high range. And so I'm looking there, so that's 38.958. And then do the reverse, 38.962. So just a tiny range on either side of our target latitude. And this is my low and my high of the domain I want to build, so I can pull those right in here. And now it's formatted as a range. All right, I'm going to just copy these and repeat that down here. Oops. And I'll pull that out so it's a little easier to see where everything is going. And you can check that everything is wired up right, because it should have a range that has a lower number and a higher number. And same, you should have a smaller negative number, and which is bigger, and so something like that. But we can play with this and change those sizes. All right, so file path. That's when it says path to the SRTM data, it's actually meaning where is that file on the computer. Params has two paths but we're data path and file path. The boxes both say path when you put them in, but we want, for today, file path. And when you put that in and you set one file path, then you want to navigate to wherever you have the, we'll start with the low res data. If you get the path right, you should see it there when you mouse over it, and the box should be gray. How's everybody doing?
Can you do that one more time?
Sure. So for the path, you want to right-click, in kind of the same place where you would set a value for a numeric parameter. This one you say set one file. And wherever you had saved that data, go ahead and go to the one that's labeled low res and grab north 38 west 96. Does that work? Everybody good? Okay. So again, don't do this. That will make it crash. So because right now it's 0 to 1, 0 to 1, which is everything. So let's grab and wire up the domain first before we grab the data. Pull the latitude and the longitude, and then you can pull the path. And to take just a little bit to calculate, I'm going to go ahead and change one other thing. Go ahead and maximize perspective. You can do zoom extents. I'm going to go ahead and increase this resolution a little bit.
Is there any reason why it would show up in the top view and not perspective view?
Zoom extents. If you do click on the perspective view and do zoom extents, and you should get it centered there.
I have set some extents.
Let's see, zoom, I type Z and then I type E. And there you go. Okay, so this is the topography centered on Potter Lake. We're looking at the low res model, so I can't see much yet. But one other thing I need to do is, if you look at what's coming out of this now, let's put a couple boxes on here. So right now, everything that it outputs points. So these are the points that were the data points in the data set. It puts out the curves, which is the topography curves, and the surface that it's generating. So I'm going to grab 3 boxes from params so we can separate those out. So you want a point box, which is the X, the curve, which is the spring, and surface. And go ahead and drag each item to that. And if you switch in preview mode, which is the green, so only items selected, you can look at each data set by itself.
What were the 3 things you used?
So grab point, curve, which looks like that guy, and surface, which is that. And they're all under the geometry tab, or geometry box of the params tab. Point, curve, and surface.
How did you make yours have more points?
If you drag this up to 0.8 or 0.7,
Okay.
so that'll add on either side. So actually the width of our area is actually, it's adding 0.08, 0.008 on both sides, so it's 0.016 degrees wide. And if you want to look at the data that's actually coming out of it, because we'll do one thing to check, just because the next question is, okay, how do I use this with my actual project? So I have this surface, how does it relate to what I'm working on? If you grab the panel, which is also here under params, you can drag the point data down to it and look at what the numbers are coming out. So it's just XYZ data, but these numbers are massive. So by default, Rhino starts in millimeters, and the ELK components will output the data matched to whatever your units are on your Rhino file. So if you want to change this to feet or inches, let's go ahead and do that. So under command, type units. Should pull up in document properties. Under model units, is everybody's millimeter, or are they something else? If you're already something else, then you're already working in something else. But I'm going to change mine to feet. Say OK. Nothing changes right away. You actually have to recalculate. So you can either change your parameters and it will recalculate, or you can just right-click anywhere on the canvas and say recompute. It redid it, so now I have to do in Rhino. I'm going to type zoom or Z and E to do zoom extents. So same exact data, but now it's in feet. So, and this makes much more sense. I think Strong Hall is like at 1,030 feet. So in terms of elevation above sea level. So this data makes sense. That's the data is showing. Okay, so let's deal with just the surface. So I'm going to turn off the preview mode, turns everything back on, but let's hide. So I'm going to group select, so drag, click, drag, select everything, and then I'm going to use shift to unselect surface, or sorry, control. When you have things group selected, you right click outside of, if you right click on top of something, it just pulls up the items for that one thing. If you right click outside of it, you get all of the options for the whole group. So I'm going to do preview off, and now I just have my surface. Okay, so I'm going to tighten this up because we're going to switch our data set in just a second here. So I'm going to go ahead and just do 0.003 and 0.003 and 0.002. And now to switch the path, same exercise as before. You right click on path, set one file path, and this time navigate to high res. I probably should make sure I got the right. Ah, no, I don't. So I should have typed. Sorry about that. Let's do this. 249. I changed my longitude to 0.249. Alright, so this is starting to make a little more sense. Looks like this is Potter Lake. Kind of hard to read right now, but this is Jayhawk Boulevard. Over here should be Cayo Fountain, and then off toward Pearson. But hard to tell without actually any context. So that's what the other component is for. So let's go ahead and work on that one as well. Okay, so if you go, let's start and get our data set. So you want to go to Chrome or Internet Explorer or whatever, and go to the second link, or you can just Google it. It's OpenStreetMap. So I did Lawrence, Kansas. Yes, Lawrence, Douglas County, Kansas, United States of America. And then go ahead and zoom in on our site. I'm going to pull this over to the side. Whoops, did not like that. Never mind. So you have the similar things to Google Maps. OpenStreetMaps is just the open source version of Google Maps, and that's where, because it's open, it has an export button. So here, now we can type in and give ourselves that same data set, but for all the metadata. So it's the streets, it's the building perimeters, it's the waterways, the roads, all of that data. So I want to manually select a different area. And the numbers I care about, sorry I have much smaller screen real estate, are these. Panel, so I can read this. You don't have to do this, I'm just going to do this for a second so I can read them. So I just want to match these to those values that I have there. So I'm going to say 38 point that, 38.963. There we go. And whoops. So, -95. I should say I already downloaded this for you. It's in the files. If you just want to watch this, you can. But so you know how I got the data. This is where it came from. Oops, the other way around. No, the other way around. There we go. Okay. So this isn't ideal because we have a parametric model in the Grasshopper. This isn't parametric, it's just a big manual setting. So in general, you could get a bigger data set, you could get a bigger view and suck that all down. But for now, I matched the perimeter to where we were working on before. So you hit export and it will download a zip file, or an OSM file, I guess. So this is all of the stuff that is in there in terms of where roads are, the labels, the perimeters of buildings, all that fun stuff. So back into Grasshopper. So we're going to come over to the Extra tab, back to Elk, and we want location. So this one says process OSM location data for use with other ELK components. So it has one input, file path. So we need another one of those boxes for file path, params, file path. Again, you can always double click and type and retrieve them that way as well. Okay, set one file path. The other data set is still under the geodata OSM. Map 2 OSM was what I sent to you earlier. Go ahead and drag that there, and now I should have items filled out here. And one thing you can see, it brought across the longitude and the latitude that we had typed. So later you can either manually set it like this, where you define what your area is, or you can go ahead and just go to Street Maps, find your site, drag this for how much context you want. And you can drag those up, and that should work exactly the same. If, like right here, you can just have it come directly from here. But now you can't change the size and the data, so it just depends what you're doing and how you're doing it. But you could turn off all of these and just drop this up there. Okay, so that's the output. That plugs into the front of the other components that come with Street Maps. So let's do generic OSM. So this, if you go to documentation somewhere here, it will tell you what all the labels they call, all the kind of various things, because they have things like buildings and trails and things that aren't roads. They have categorized under basically miscellaneous. And when you look here under what it's telling you, so it's easy, you match the O to the X, or the O to the O, the X to the X. That turns it on, and then it wants to know what are the key feature you're looking for. So the example they have here is building. We'll go ahead and use that one. So right click on the K and set text and type building. And so it says I'm outputting an organized set of points and a set of names. So that's all the buildings that was in that view that we downloaded from the site. So the points, you can connect them together. We can do polyline. So double click and do polyline. And drag the points output to the vertexes. You can go ahead and hide, when you right click, you just toggle this on and off with preview. It doesn't change to preview or show, it just changes the color of the box. And there's your building data. So Marvin, Strong, Design, whatever this building is, Stadium. That was all the ones that fell within the view. They're down on the 0, plane. Our data is up at 1,000 feet, but we can fix that.
Where did you get this help plugin?
I just Googled, I just looked on Food for Rhino for topography in Grasshopper, and somebody wrote this. It's not easy, but it's not impossible to write the plugins. That's why there's so many of them. It's just people that haven't kind of experience with, I think most of them are written in either VB or C#.
So is there like a website you generally go to for these kind of plugins?
Yep. Yeah, Food for Rhino. That's the website. It's all of them collected together. So it has Rhino plugins, which I think like RhinoCam and that sort of thing follows, and then Grasshopper add-ons. And so that was my search earlier this week after your request, and then read about it and said, hey, this does everything that you want it to do. Sweet. And they're almost all free. Even the ones that aren't, I think they just ask for donation, but that's not, students don't have to donate. All right, so we'll do the same with Waterway. It's here, grab the O and the X, and then it outputs all the different water, so it's kind of the opposite. It doesn't give you choices coming in, it just gives you the choices coming out. So this is all the different types of categories of waterways. In our case, only one of these is filled up, Potter Lake. And so we'll grab this, paste, and then I'm going to hide this guy again because I don't like the points. So right click on the label tab, the label for the box, and get preview off. So there's Potter Lake. So this is good, confirms that we're in the right ballpark. You know, we said we wanted that to be the center of our site. There it is. The last one you can grab is roads, major roads. They both work the same. Highways, all three of them. In this case, I already checked. There are no, it doesn't consider there being any major roads on campus. Everything's minor road, so you don't have to grab the other one. It's empty. And then just same thing, grab the O, grab the X, hide that guy, and copy, paste. Okay, so there's the road it grabbed. So we're just off of whatever that road is, so it didn't capture it in our set. But we have Jayhawk Boulevard, all of these ones down underneath. Everybody getting all that data to show up? Okay, the other thing that comes out of the roads and the generic is the labels, if there are any. So this is, you know, Crescent Road, Jayhawk Boulevard, Memorial Drive. Here we get the building names. So in order to show these labels, you can show them also in on the model. So we want to go to Vector, Tab, Point, and under Point is a couple items for letting you show textual information. Let's see, I think 3D text tag will do, that'll work. This is the one with more options. So it wants to know the location, so the point for that, the text to display, the size, and then I don't think we care about color or justification. But so we need a point. So we have a line, but we don't have a point. Let's do the center of these buildings as our target point. So under Curve, Analysis, you have Center of Polygon. So it'll find the average of the points, which is a helpful thing. So just drag that to there. And it's doing a few different types of centers. They all are approximately the same. So let's grab location and pull it down from average of polylines, average of vertices. Yeah, that works. All right, so the next one is text. So we have text here. This is one of those times, though, if I drag this, it's not going to work. And so I'll go ahead and do that. I don't have any labels, although I need to actually make it a lot bigger. So my units are in feet, so I'll make these 10 feet. So the problem is there is every label for every point, which isn't what we wanted. And this is a little bit what we talked about last week. So this component outputs the points as structured data, which was helpful here because, you know, they all had different amounts of points. It was nice that it did that separation, because then when you made the lines just knew what points to connect. Here you have them in a list, and you know the difference because when you look at something that's in a tree data, it shows up with that weird numbering scheme, and you don't see anything of what the data actually is. When it's just a list, you can see the data in the preview when you mouse over it. So what you need to do here is make this structured data as well. And the term for that is grafting. So if I do this, right click on that and I graft it, it makes a data set for each. So graft and flatten are the opposite of each other. If you wanted to see, conversely, if you wanted to look at just the flat data here, just see the data, flattening it, now I have just points. So I'm going to go ahead and undo that, but that's the back and forth with data when you have it is to either flatten it or graft it. That means make it structured or make it just a big list of items. So we don't care about these points anymore. I'm going to hide them, preview off. And if you really want to, there's some tools in here to manipulate the strings. If you wanted to pull out all the yes, because I think it would just say no if it didn't know the name of the building. That, if you want to mess with it, it's under math or not set. Here it is. Some of this sort of same thing you might have run into in Excel on how to format and manipulate text, but I'm not going to mess with it for this class. All right, so we now have the topography of the site. We have the data from OpenStreetMaps of all the buildings, the waterways, the roads. And so what are we going to do with this? So, you know, one thing that's often helpful is making a model of the site when you're doing iterations with design going through, is to have that site with your site carved out. You guys have a few 3D printers here. You have a couple other options for fabricating it. We'll go ahead and make this assuming that we were going to put it into the 3D printer and print this out. So what you need to do is give some volume to this component so you can actually make it. So I'm going to leave this alone for the moment, all these, and we'll come back up here to our surface. So the simplest way to give it volume is just to extrude it. So all the things that we're going to work on here are going to be under the Surface tab. Freeform should have an extrude, or you can double click, type extrude. The one you want, if you mouse over it, is extrude curves and surfaces along a vector. So basically it's give it an edge or give it a surface and say extrude in a direction. Direction parameter is empty, so you can go ahead and drag the surface here, but it's not going to update. You can delete this if you have this here. We're done looking at the data. I think everybody understands now and believes that it's the actual site. So direction. So vector is the input. And always you can get a sense, even if it doesn't tell you exactly. You can right click on something and say help, and it will tell you about it, a vector. You can look at the icon there, because the icon will match the icons that are the param icons. And so if you go find it there, it'll tell you. So you want to construct a vector. So vector, luckily, is under vector, and vector, vector, vector. Here we go. So under the vector tab in the vector box, and we want this just to go in the z direction. The north and the south data was in the xy coordinate system. So we would just want to give ourselves volume so we can print it in the z. I'm going to grab unit z. And so this is the multiplication factor. So this says how far do you want to travel in that direction. I'm dealing with feet, so I'm going to say negative 200. I want to take the surface I have and put, well, let's say negative 400, and go down 400 feet. So I have right-click on that, set the number to negative 400, and we'll drag that up to the direction input on extrude. And now I have my volume. Still can't 3D print this. This is usually you have to start with a flat base. The 3D printer has a flat base, so it likes to start with there, and then it will stop and give you your geometry. So we just need to figure out how to trim this. Unfortunately, this is where Grasshopper isn't as intuitive as it could be in terms of how you go about doing that. I'll show you one way to do it. Yeah, it's just, there's probably other ways. If you find better ways, we'll talk about that in the future. So
sorry, can you loft it as well?
Yep. You can loft the, well, what do you?
Just to get the thickness that we were just talking about.
Yes. If you had, you can make a base and a top, and you could loft between them. The trick there is, so the loft is just going to give you the edges. So say we made a rectangle down here. Is this kind of what you were thinking? Rectangle
Yeah.
there, loft that to the perimeter of this.
Right, because if
Yep.
you're going to CNC that, I guess you'd want a flat base.
Yep. So yeah, we're going to make the flat base. The only reason I didn't do the loft is just it's a little weird how you. Well, we can do it that way. That's fine. That works easy too. So we'll do that. So the base is easy to figure out because it's. You just want to know the perimeter of this. If you look here, so when we did with our data set last time, when we were figuring out all the boundaries of it, when we were doing the remapping, we used minimum and maximum. So we want to do the same here. We want to figure out what's the minimum x value and y value and the maximum. So I'm going to take under vector and deconstruct. So now I have all my x's and all my y's. So I'm going to grab min max twice, copy, paste. And here's where we have to do that opposite. So right now it's telling me the min max, but it's telling me for every single data grouping, and I just care about the overall. So I'm going to right click on N and say flatten. And so if you look at the difference between these two now, so this is the structured data. I have 20 rows of 14. Here it's just a big pile of numbers. It's all one list. So the output here is your minimum maximum for the whole data set, and here it's the minimum maximum for each row. So we're going to flatten both of those. So that's this is the dimensions of my rectangle now. So let's do rectangle. And there's a couple different rectangles. Make sure you have the one that's got base point, x dimensions, y dimensions, and then we don't care about the radius, but we just defined the x and the y. So go ahead and drag those two min maxes there, and now I should have this.
What are the minimum and maximum under?
So minimum maximum is under math, domain, and bounds it's called.
Okay.
Sorry. So if you double click bounds is what, I don't know if min max will bring it up.
Yeah.
Yeah, not so much. So bounds should. Okay. So we don't need the extrude. So
Flattening do exactly? Like I saw that it went from a bunch of lines to a square. What is that kind of?
So let me unflatten this. Let me disconnect this for a moment. So the Y value right now is it's organized in terms of rows and columns. So it's leaving that data structure in there so that you can do things where you need to go and find this exact column grid, column line. Kind of the example we talked about last time when you had to deal with matching up the data from the image mapper to your point grid. You needed those to all be both organized in the same grid structure so that when it said make this circle, half an inch and make this one 3 inches, it knew exactly which one to match it up. And so right here it's giving you that same data. In this case it's the curves. I have 20 curves here, 20 rows, and then each curve has a certain number of points in it. When I did the min-max here for the structured data, it said, oh, you want the min-max for each row. You don't want the whole group. So if you look at the output here, again, it's in this sort of notation for array notation. But if I grab, you can always look and see what's going on inside under panel. So here I have every row min and max. And so this one, since this is the row data, there is no difference along that whole row. Every value has the same Y. So the min-max doesn't mean anything here. So the flattening, what it does is it will take all of that data. When you say flatten, it makes one big list of all those points. And so now there's only one output because I'm looking at all 294 data points all together. And that's kind of the opposite of what we're doing here. Here we had points in a data structure and then labels flattened. And so we did the reverse. We used graphed to add the data structure to it. So it doesn't need much data. It just made a set of data. There was 14 values, and there's only one in each set. If you look at the points, that's where there's a little more difference and uniqueness to it. So for each one of those buildings, each building is its own. It's the first number in the column, 0 through 14 or 0 through 13. And then the number of points that outline it varies. So it structures the data so that when you deal with it, the polyline command knew not to connect Strong Hall to Marvin Hall and Snow. It stays within the bounds of those groups. Anyway, flattening, grafting, they're like the weirdest labels ever. I mean, I don't know why. They, I guess, fall under the idea of tree, graft branches on, and I don't know. Flatten doesn't make sense to me, but it is one thing it's there. Hopefully you don't have to, like, Grasshopper's designed so you don't have to use it too often, but understanding why it's there. So like right here, we want to know the entire boundary of that set, not just each row. That's where you have to kind of understand it so you can manipulate it when you have to. So I'm going to turn this back on. And there we go. So now we have, so I went ahead and deleted the extrude. So we have, I'll turn off preview. So we have the surface and this boundary at the base. So the boundary at the base is down at 0, 0. If you were dealing with a site in the mountains in Colorado, you'd be even further apart. You'd have 6,000 feet and 0, 0. So let's go ahead and make this base be up closer to the area that we want to deal with. And let's say I want a minimum thickness of 200 feet. That's like the amount of girth I want to have the 3D printer make. So that's where we'll manipulate point. So we have one more value here, and we can do the same thing. We're going to copy this bounds one more time and drag the Z value. Okay, so this should be my minimum elevation and maximum elevation. So I need to get at the minimum one. That's when I know that's kind of the lowest point that I'm going to be carving out. So under math, under domain, you can deconstruct domain. All this does is it takes that range and it splits it into two numbers. So you can grab either the larger or the smaller. So move I to I. And now I have my start, which is the lower elevation, and the end, which is the top elevation. So I'm going to go ahead and make a point here. So I'm using the point at the minimum elevation as a starting point, and I want to go down 200 feet. So just going to subtract. It's under math, operations. It's going to take that start elevation, map it to A, and then right click and set this data to 200. Yep. And I set the data to 200. So now I'm going to set the bottom of that loft, the bottom of my surface at 200 feet, below the minimum. So I should have, my value was 925, now I'm at 725. So I can't just drag this value to the point. It needs an actual XYZ coordinate. So we'll do vector, and under point, construct a point. So the XY is still 0, 0. I'm going to go ahead and grab Z. Okay. Now if I drag that point up to the point on the rectangle, it should move that base up to there. Maybe 200 is too thick, that's where you'll change this. It's really the fabrication method that you're working on and you were worried about. 100 might be too thin, maybe there's a big basement below the site that I'm working on, but it's flexible. I'll go back to 200, okay. So for loft, you need two curves to loft. So right now we have a curve and a surface. So we need to get the perimeter of this surface. I think that's under, yeah. So under the surface tab, analysis, there should be B-rep edges. I think this will work. I'm going to remove the vector. We're not using that anymore. So surface to B-rep edges, and I should get, okay, so it says naked edges, and then these are interior edges. We don't have any interior edges. So they're separate. We need to join them. Join is just what it's called. And there should be a join curves. That's the one you want, not join B-reps. And drag this here. Now I have one closed curve. So I have the rectangle and the closed curve. If you loft, which is also under the surface tab, freeform, loft. Loft is what we used last time when we were starting our surface. If you remember, you have to drag, let's see, rectangle. So you drag one, you drag the other one without holding shift, it will just replace it. So you just want to drag one, hold down shift and grab the other one, and it'll let you connect them both. Alright, so this one is not happy from what I did. It's that same problem. So right now it's got two data sets. And it's thinking I want two different lofts because I have structured data. So this is one of those things where you just flatten that. Because what you want is just a list of curves. Whoa. See if that will work. Oops. Okay. There we go. Alright, so I did loft options, align sections. Now I have that. So if we look, this is still just, so go to preview mode, so you can make sure you're just looking at one piece. So the loft is just the edges. So now we have to marry that with the bottom surface. We actually don't have a bottom surface yet, and we do have a top surface. So the way you make a surface from a rectangle, it's also under the Surface tab, Freeform. Boundary surface creates a planar surface from an edge. Okay. Now we want to join these three things together. So join again, and this time join brep. And then drag the boundary, the loft with shift held down so you can grab them all, and then the original surface. Everybody get that? Alt join.
Why do you guys get edges to the boundary lines? It was just
Okay, so forgot the recording. Here we go. So if you want to 3D print this, you export with Bake. Bake brings the geometry into Rhino. Say OK. You have your geometry. Save as STL file. Once you have that STL file, you'll want to come to Makerware. Either, I think it's just a free download for the software. And you open up the STL file that you created. Great. Let me try scaling this down. So this is, you know, a couple 100 feet. Whoops. All right, so 0.2 feet. That's a much more reasonable. And this is where you may even have to change units back. If I change this now, it shouldn't change the. It will automatically scale that. Alright, so even smaller, 2.4 inches. That's definitely printable. We'll see about this. All right. That's your SD card size version. There. All right. So there you go. 3D printed site. For MakerBot, and you can talk to the guys in the ARC, the other class, but you have to be connected if you want to make it, or you save it and it'll save what's called a thing file. And oh, my service is turned off. When you make it, you make a file that is something that you put into the MakerBot, and then it just sits there. It would take a million years to print this, but okay. So let's go back here. Units. I'm going to turn it back to feet. There we go. Okay. So usually, though, the first thing you do with site is you have the context up on the top, and you also have where you're going to actually carve out, dig your foundation, and put the model. So let's do both of those things, because all of that data is down, at the 0, 0. It's easy to move it up to the top surface. So this, we're going to use the surface, which was coming out of the topo command, or topo box. So down here, let's just pull the buildings up and the streets. So you want to project object onto surface, or brep. Brep is also Grasshopper for surface. So project has curve, brep, and direction. Direction you can just leave as what it is right now. That's means it's in the Z direction, so it's just going to project these straight up. I'm going to project the curves being the polylines of the buildings, and the surface I'm going to drag and be there. So there's my buildings. And you can just drag the same outputs for the others and hold down Shift, and it will add them. And here's where you can kind of get a sense of the relative accuracy of this data. In reality, the edge of Potter Lake is level. Otherwise, it would be all kind of spilling out. So that's where the resolution of this site data, you can get a sense of if it's good or bad in terms of if it will work for you and your design. I'm going to go ahead and, since we said Potter Lake was our site, let's actually pull that out of this this geometry. No, that's fine. It's there. It's fine. Let's go ahead and back in Rhino, Control Tab, reset this to the top view. So keep doing Control Tab until you're out of perspective and just on the top.
How do you reset your camera again? So that it's like above the object?
Control Tab will switch the view.
Yeah.
And then in your top view, is it looking straight down on it?
No, because I think camera's like way off.
In top. I don't know if this would work if you right click on it. I think plan also does it. Plan. If you type plan, it should bring it back to the top.
Okay.
Does that work?
No. I don't really know.
You can also just move the camera around with the pan to get it there if it's... You can stay in perspective and just kind of move it where you're looking down on it. That'll work too. So I'm going to, in Rhino, draw the polyline that defines the perimeter of the building. So polyline, I'm going to type in polyline. And then I'm just going to start outlining my building. F8 is ortho lock if you want. That's like, now I can only draw up and down lines. That's straight out AutoCAD. Okay, so any boundary will do. That's my first one. That's a little bit bigger. It's like 20 times bigger than Stronghall, but it's the new basketball dormitory. Perspective, okay. So I'm going to go ahead and drag. So I'm in perspective. I'm going to go ahead and, if you have your the colorful, once that line is selected, you guys should have this. You guys have this blue, green, red arrow thingamajig.
How do you make that come up?
If you don't, it's under this thing down here called Gumball. Gumball turns it on and off. So it's one way when you're in a perspective view to make sure you're dragging it in the right dimension. So I'm going to go ahead and just, you could also switch to the right view or the front and do the same thing. Just kind of pull it up so that it's not above the geometry and not below. Okay. All right, so now we're going to do a volume out of that in the same way that we did the other one. But this time I don't have this in Grasshopper. This is just in Rhino. So to import that geometry, we didn't have to do this yet today. This is under params. This is a curve, so I'm going to do that. Hang on. And right-click and select one curve. I already had it highlighted, so it immediately said that's the one I want. So now I have, if you mouse over it, should say reference polygon or polyline curve once it's imported. So right-click on the curve and say set one curve, and then select it in Rhino. Is that letting you select it? Okay. Okay, so now I want to make a surface of that. Make that the base of the hole we're going to dig. So surface, freeform, boundary surface. Boundary surface makes a surface out of edges. If you want to see what it's doing in this, if yours is all red, click on the green, highlight these two. You won't see this previewed because it's on top of the curves. It's right on top of it, so the curve is showing, but it's working because that is there. All right, so we need to extrude this surface vertically. We're just going to build a high-rise. So extrude. There's a couple extrudes. You want the one that's got the straight line. Extrude along vector. And we did this one a little bit ago. We didn't use it, but so the curve or surface, we'll do the surface and the direction. So we want it to go straight up. That's under vector. So vector tab, vector box, and then Z vector. And we need a lot of space. Maybe this is a parking garage for Marvin. So we'll make 200 feet. Now that in context of the building or the site. So it's pretty deep. I don't need it to be that far underground, so I'll click on the curve and I can drag it here and it'll update my grasshopper. Alright, so that's more like it. Alright, so if we wanted to 3D print this now, and this is our site, we need to dig that out of that volume so we can iterate the paper or the physical model we're going to be making. You want to Boolean out this surface from the original. That is under intersects. The intersect tab has this guy. This is all the sort of commands that you would think of in terms of dealing with clay. Scooping it out or putting stuff, combining two components. You want the solid difference. So this says, okay, take one and subtract it from the other. So it's under there, or solid diff. And you want the one that is this guy. So if you look over and highlight, it says this component performs a solid difference. Alright, so I think it takes away the second one from the first one, but we'll try it. So the output of this is a B-rep, or surface. This is a surface. If I go to the preview mode, there we go. So again, you could repeat that same process and print this out, and that's kind of your physical model start. And this one's a little weird because we have live geometry. This is based on this curve. If I move it, it'll take a moment, but it should update, change. The way that you can manipulate vertexes on this polyline, it's kind of hidden in Rhino, but I know it under curve tools. So you have this toolbar in Rhino, curve tools, and then there's this guy. I don't know what it looks like, but it's points on, points off. If you click on that and you select a curve, or if you have a curve selected, so if you click on that and then you select a curve, it says press enter when you're done. So now I have these points, and now I can click on individual points and move them. I'm not sure what it'll do if I'm in perspective mode, so let me switch to top view. Okay. Yeah. You can use the gumball to make sure you move something in the XY if it matters. But that's a good way where, this is a place where you can kind of see what makes sense for Grasshopper and what makes sense for Rhino. You could program all those points into Grasshopper, but it would be a pain in the butt to move them around. Here, this is still really freeform. You're doing geometry design. You want a little bit more freedom. So leave that geometry here in Grasshopper, and then you can manipulate it. And you can also kind of rapidly try different things too, because if you have a circle, let's try that there instead. So you just swap this out. You say set one curve, grab the circle, it'll update now for my other base. So final kind of presentation model. let's grab everything. We only care about, so do preview off on everything. We care about this one, so I'll turn on the final solid difference, and then I'll also turn on the project geometry. I'm not exactly sure why it shows up that way with the dotted lines. When you zoom in, it shows up better. But a couple cool things there, especially when you have to do kind of the beginning of the project and do analysis on your site. This OpenStreetMap data is really good. It's just as good as the people that have put in it. So certain localities have really good data, and certain ones have kind of not that much. If you go to New York City, it has highly curated data and lots of information. So let's just do a quick New York City. There we go. So if you just grab a little bit of Manhattan, this will take a little bit longer to download because this will be a lot of data, but uh-oh. I've overextended my download limit. Alright, I'll zoom in a little more. There we go. So I'll import this. So this is where you could start to answer questions like how many schools are within 500 feet of my site. All those, things that start to talk about when you have maybe a multi-purpose program with lots of different activities and you're trying to validate and figure out what does this community need. Let's grab this and just do a little spelunking in the data. Alright, so let me move this back over.
So really, could you just keep this Grasshopper file and then just plug in different coordinates and it would
Yep,
do it?
that's the idea. So, okay, so this is that little chunk of New York that we downloaded. And this is one where there might be a subset. We can go back and check, maybe school. Nope. Church. You can try apartments, see if that works. Alright, so I don't know how to make that work. But I think if you get the right data set, the right value that New York has classified its values, then you could say, okay, here's the here's the center of my site, and then here's all of the distance to each building that matters. There we go. And you can kind of see, if you want to, you can just open these as a text file and start to see, so building, so this is all that data and the way it was coming in. Alright, so the data here that they have is height. So that's helpful in terms of, because New York's a very flat site, building data, building height, that should be something that we should pull out of that data set. So if we come back here, let's try height, see if that, I don't know how to get to that data. I have to figure that out, maybe next time. But you building up the context and quickly getting to the end is kind of the idea. So you can go about designing rather than spending half the project building just the site and then going from there. So, any questions about this data? For you guys in the digital fabrication, are you guys using the 3D printer as one of your?
We haven't yet.
Okay.
But
I think we got it.
I would say like our last project, I think our last one is we just utilize the CNC and like the transfer project, so it doesn't look like we're looking at the 3D printer.
So in terms of building that, then you would be building a site with layers, because you're going to have flat.
Yeah, you do layers or CNC is
CNC depth, is that,
right.
you have 3-axis? Okay.
Yeah.
Okay. If you were doing it the old-fashioned way, the lots of chipboard and cutting sections, then you can take this same result. And there's some quick ways to get the topographic lines that you could then print out. So there's one shortcut under.
Can you bake that?
Bake this? Yeah. You can bake any object all along the way. The only thing that won't come out is numbers. I don't know what they do if you bake them, but yeah, this guy you could bake. Let me change it back to the other. There you go. That's real geometry. If you cared about the curves, there's a contours line under intersect tab, math. Contours, create a set of B-rep or mesh contours. So this one cares about, so it's the surface you want to put contours on, the base point of your first contour, which we already have a point. We made that point for a rectangle, so I'll drag that forward. And then you have to tell it the distance. What's your elevation between your contours? So say we care about 5 feet here. There you go. And these should be structured, again, structured data, so lots of those are a single curve all the way around. But if you look, at some point you're going to have multiple curves because you have different different items at different elevations. And this is the way where you can, you can bake all those curves and just find them, but if you want to kind of keep it organized and do one at a time and make sure you put things on layers or whatever you're going to do, so you can make sure you cut out the right curve and print out however you're going to do it, the printing or the digital route. So this is all structured data. I'm going to go ahead and simplify this. This one has this leading 0. They're all 0, it doesn't matter. So now I have this list of 0 through 68. If I go to sets, tree, there's this one that says select branch. So in Grasshopper's labeling, the number column on the left is the branch. And so if I care about branch 65, so I'll drag that there, I can just grab the individual branch. So that's the thing at the same elevation. And this is where it's helpful sometimes to have a slider. And you can, so I'm going to set this to, let's see, 68, 0. So that's my groups that are at the same elevation. Yeah, and New York City in the background. All right, 5 minutes. So the assignment, and we can just talk about if it's due next time or due Friday before spring break, is 2. You have a choice, and you guys can tell me which you would rather do. Take one of the exercises and extend it. Add some additional functionality to the ones we did. We did a few different stopping points on attractors in terms of adjusting and doing perforations or geometry based on a grid. We started with the surface modeling last time. Next time we'll finish that. So if you guys would rather have to the end of next week, then we can do it that way. Or as a topography example is the other one to choose from now. So I don't know, do you guys rather be done next Tuesday, small, or next Friday? Okay. All right, so the examples, and it can be either ones from this week, previous week, the week before, or next week as a starting point, and then extending it in some appreciable way where it's doing either things differently than the way we did it or extending it past. And it's just getting started because we actually are going to have things to turn in as we start to do the project. So you guys had it easy for the last 7 weeks. So, all right, so we'll go over again next time what the starting points could be. I'll email that out this week with the ones that we're going to go to next week. So we didn't get to it this week. We'll do the thing we started last time with the skin, the skin fitting on kind of amorphous shape. We'll do that as next week's exercise and have some break. So. Any questions? All right, thank you.